All right, well, let me get this started. I'm Jim Mielke, one of the speakers, and we'll introduce ourselves just in a couple of minutes. But I do want to get us kicked off at the appointed time here. I do see a lot of familiar names in the group of people that have signed on at this point, so welcome. And for those of you who I don't know, welcome to you as well, and perhaps we'll get to know each other a bit after more after this webinar. So I want to introduce the webinar here just a bit. So go to the next slide, if you would, please, Robert. So for those of you that are interested in continuing education credits through the AIA, this is a registered webinar. Kaufman Engineers is a registered provider of AIA approved continuing education. There is a provider number there will be information for you to follow up. Robert, next slide. So as you go to the need to get information, the details of the information about this webinar, that's all presented here. And again, this information will be repeated for you to be able to follow as you enter the link. Robert, again, next one. You'll go to an AIA link that is, for those of you that are familiar with doing this, this will be a familiar link for you probably. That's where you enter the details of this particular webinar to get your particular credits. So next slide, Robert. So this is a webinar that the University of Maryland and Kaufman Engineers are putting together collaboratively. This is a topic that came about as one of Robert's colleagues, Bob Libby, contacted me back about 3 weeks ago now, I want to say that there was this software that was available for development of pedestrian plans for buildings as the campus may be interested in as we consider reopening for the fall semester. And as we got to talking a little bit about this capability, we said, gee, this might be something of interest to a broad community. And that got us to thinking, gee, let's put a webinar together, and here we are. So want to thank them for the initial idea, first of all, this. I would say we are moving forward with analyzing a set of buildings for the University of Maryland College Park campus. I saw at least one of the names of the students who are helping me with this, and maybe there are a few others who have signed on since I started. So welcome to the group of you, and thank you for helping out on the project. We'll talk a little bit about just the background of what's of why this type of information is useful. Talk a little bit about modeling in general. Then I'm going to transition and hand this over to Robert, who will talk some about the COVID-19 pedestrian simulation modeling for this application, and then we'll go through a wrap up. Next slide. So for those of you who don't know me, I'm a professor and chair of the Department of Fire Protection Engineering at the University of Maryland. I get involved in the response of people to fire. I get involved in a variety of projects. Response of people to fire is one I've been involved in for many years, along with smoke control systems and advanced fire detection. Robert?
Yep, thank you, Jim. Robert Gerard, I'm a fire protection engineer with Kaufman. My background is actually structural engineering, so I went to Cal Poly, but not for fire, and I'm probably one of the few fire protection engineers that did not go to Maryland. Actually, I went to school in New Zealand, of all places, but I've been pretty strongly involved in a lot of different performance-based aspects, one of which being pedestrian simulation modeling. So I'll be talking a bit more on the modeling efforts, and then, as Jim mentioned, we'll be talking a little bit more on the background.
Okay, so the need for pedestrian planning and why we're all here is in welcoming people back to buildings and facilities while maintaining social distancing. There are some requirements in order to do that. You want to develop plans to minimize queues, so there aren't lots of people gathering at doorways, and then also eliminate the people passing each other in narrow corridors, stairways, and doorways. Next slide. So with these pedestrian plans, we would seek to identify then entrance versus exit doors, up versus down stairways, one-way directional flow in corridors and aisles. Perhaps some of the stores you visited, you see some of those markings on the floors now, in particular aisles of the grocery or the Costco or wherever it might be. These plans, as they develop, they need to account for the number of occupants that are going to be there and be coming in, and also the distribution of these occupants. So where are they starting? What's their final destination? What part of the building are they going to? Or maybe they're exiting the building. Next slide. So in general, there are simulations that are available, have been available for a number of years, as I'll talk about on the slide after this, that provide an estimate of the movement of people throughout a space. The one model we're going to talk about today is one such model that provides that estimating capability. Robert? So just a little bit about pedestrian modeling, so that this doesn't appear like just magic happening, that these models have been around actually for quite a while, for almost 40 years now. They started out with just simple hand calculations, and it basically used a hydraulic analogy that approximating people to be the same thing as a fluid particle. So fluid traveling down a pipe was the same as people traveling down a corridor. And as the fluid leaves the pipe by way of the end of the hose, that's the same as people traveling out a doorway, basically, or at least that's the way it was handled in an analogy. In the second generation model, just still in the 80s, early 80s timeframe, these started to become computer-based models of putting these same hand calcs into some software, and the software could help the bookkeeping then where there are multiple paths involved. But you were still looking at the mass of people in the building, these models at that point. It wasn't until the third generation models of the 90s that we now started to track individuals. So they could track when I'm leaving a particular building, when Robert's leaving a particular building, and occupant number 112 was leaving the building. Where was occupant 112 at any particular point in time? The fourth generation model came in the latter part of the 90s, where they started to apply behavioral aspects. So there could be some very simple decision processes included in the model, and perhaps having some delays of when people started their evacuation. That started to get into the fourth generation models. Now we're into the fifth generation that have been around a better part of 20 years, this category. So maybe we ought to start talking about a sixth generation, I guess. But there's a fifth generation model that now there's a more behavioral aspect. So there's still a lot of that fluids and that fluid flow analogy that's kind of the heart of the model, but that is now altered by this behavioral aspects. So now people can alter the way they move based on the conditions experienced. And one of the conditions experienced would be very relevant for us here is what other people are around and how close are those other people. Next slide. So a couple differences we're thinking about. So we're using what are called evacuation models for this purpose now in pedestrian planning. And what are the differences, and how easily is it that we can adapt that evacuation model into a pedestrian model? The evacuation models, everybody starts inside the building. They initiate their movement more or less at the same time, though there may be a little bit of startup time, but they're basically all within a few minutes starting their evacuation nominally at the same time. And they all move along particular paths to get out of the building. In pedestrian movement, different story. People are starting either outside or inside the building. They're initiating movement at various times, and they're moving along a path to either to get outside the building or reach a destination inside the building. Think again of a campus building where at the change of class, there are some people leaving a class and they're leaving to get outside. There are others that are coming in to attend the next hour's classes. There are different startup times. People come to class at different times. And, some are arriving 10 minutes ahead of time, 15 minutes ahead of time. And there are some that are arriving right at the beginning of the class, if not those few who are 3 or 4 minutes late. And I don't want to call out names here of anybody that maybe did that, but it's a variety of times, as opposed to when class is out, they're basically leaving en masse to go to the next class or to some other activity. Next slide. Do keep in mind that these simulations are not able to replicate exact movement of the people. These are going to be approximations. These are going to be estimates And as such, I have to emphasize that whatever we do with the models, this ends up being a decision aid to those people that have to develop these plans. And it's an alternative to getting out a floor plan with crayons and then writing all over the floor plan. So it helps inform the development of these plans. We do need to remember that people are not robots, that they're not going to respond in a lockstep sort of way. They're going to move as people move. People think, they help one another, they tend to travel in groups. Robots don't do any of those things. So if they are in a group, it's important to recognize that people are going to tend to move as fast as the slowest person in the group. So if you're with a group of friends and the one friend doesn't walk very fast, you tend to stay with the friend and not walk on ahead and tell them, hey, yeah, you'll see them tomorrow or whatever. So we do need to keep in mind that there are these limitations, and there's just so much the evacuation models or now these pedestrian simulation models can do for us. With that, I'll hand this over to Robert to continue with the rest of the presentation.
Great, thanks a lot, Jim. Appreciate the background there. Before we launch into this, we certainly hear a lot about best practice information, guidance, things like that. So I do want to point out that this presentation and a lot of the charts and the information that we're providing here are based on some of these primary sources, namely CDC, NIH, NIOSH, a couple different groups. And so I've tried to put links in here to a lot of the data sets. If you have the slide deck, please feel free to check those out yourself. But with that said, we'll hop right in. So I don't think this is probably news to anyone, but we had this initial first wave. And so of course, we're trying to figure out what's been happening. I think with the advent of testing, greater information, a better understanding of what's happening, we experienced shelter in place for a while. And then especially over the last month, we're seeing a number of different parts of our country reopening. And in general, pedestrian simulation modeling is trying to help organizations and clients to understand ways that we can reopen, but also integrate some of the new learning around some of the risk mitigation efforts to try and minimize the spread of COVID-19. And I think this is particularly relevant right now, especially in the last couple of weeks, that as we have started to reopen, we are seeing a resurgence of cases, that we're seeing increase in positive test cases. We're seeing increases in hospitalization, unfortunately, in some of these fatalities. And so I think it's important to be aware of what's happening in the world around us. And hopefully that helps us to be informed about the risks that we decide to take as we move back into these environments. Again, kind of goes without saying, I think everyone's familiar with this, contact fomites. Sanitation is very important to try and mitigate some of that spread. But today we're going to focus more on the airborne. And so airborne transmissivity in the effect that if you have an infected person, that there is a potential to be exposed to the virus. And it seems like if we're in close proximity to them, there's a higher risk that we ourselves could potentially be infected. So I think we've all heard of these public spaces too, that there have been a number of what are referred to as super spreader events, where you might have had one person that was infected, that was in close proximity to a group of people, and unfortunately, a number of that population were infected and go on to spread it to other people. So this is a type of thing that we're trying to mitigate as best as possible through greater analysis and understanding of what some of those risks are and what sort of implementations we could possibly use to try and mitigate that transmission. So there's a couple different ways to do it. I think there's quite a few references and resources out there. Building controls, HVAC, of course, are one of them, trying to enhance some of that ventilation. But with respect to pedestrian simulation modeling, we're really focusing on physical and social distancing. And we'll go into a bit more detail about what we mean by this, but effectively trying to create distance between different occupants, patrons, populations. And taking a step back for a second, this is all part of the bigger picture of trying to understand, as we're trying to reopen, what are we actually trying to do here? Of course, we're trying to get back to work. We're trying to achieve these business continuity, operational needs. We're trying to keep the economy going. There's a number of different factors. And of course, those are kind of the realities of the situation. But at the same time, well-being, hopefully, and really should be one of the top priorities as well. So protecting our employees, our colleagues, patrons, a number of different people that can potentially experience a higher risk. as we enter into these environments. So what are some of the things that we can do? There's a lot of guidance out there, sanitation, facial coverings, and we're going to focus more about how pedestrian simulation modeling can be used to help enhance that social and physical distance. So when we get into pedestrian simulation modeling, as Jim mentioned earlier, traditionally this is going to be around having fire protection engineers, generally, evaluating different building spaces, the response of different emergency scenarios. Oftentimes, a fire is going to be one of the more common evacuation scenarios, but understanding how humans are going to be behaving in these events and making sure that they have the capability to evacuate in what's considered a reasonably safe time. But of course, we're in this new environment where we have COVID-19 and there's this threat of respiratory transmission that's constantly around us. So there's new considerations. And there's ways that we as fire protection engineers and designers and modelers can incorporate this traditional technology and involve some of these physical and social distancing parameters and implementations to be able to simulate what this could potentially look like within this built environment. So what do we mean when we talk about physical and social distancing? The way that I interpret physical distancing is really through an evaluation of static conditions. So there is a good amount of guidance. I think AIA has some great resources in particular to understand looking at a building floor plate, and this is a static environment, so a non-moving, continuously occupied environment. What can we do to create physical separation from people within their locations? And so I think probably one of the most common ways that we've seen is separating desks far apart from each other, putting up barriers in between, trying to physically create that different distance. But what about social distancing? We as social beings, as humans, engage, we move, we interact with people. And this is really the biggest challenge that we're facing, that it's relatively simple to look at a static environment, but it's relatively difficult to look at a dynamic environment and try to evaluate and implement these different modifications based on how people can move within these spaces. So best guidance right now around these dynamic conditions around social distancing is really trying to enforce that 6-foot separation between ourselves and our colleagues, other people within locations, trying to implement some of these screening and temperature checks to try and identify who could potentially be at risk for infection and try and limit those exposures or populations. And then in addition to that, trying to minimize the amount of interaction. So like Jim mentioned, some of these bottlenecks, like at vertical paths of egress, entry, exit locations, things like that. So what can we do as building operators and managers to try and mitigate that risk and try and minimize that interaction? A couple key considerations that go into the simulation modeling is firstly, understanding the built environment, understanding human behavior, and this is where fire protection engineering in particular has a very strong and rich history, and then incorporating some of those COVID-19 management procedures. So within the built environment, understanding the way that I kind of conceptualize it is, what is the architecture and engineering around these spaces? What is the pedestrian domain? What is the front of house? What is the back of house? What is occupant behavior within these spaces? How are they going to respond to each other, to the different building systems, to the intended occupancy use of the space, a number of different parameters to be aware of. And especially on top of that, understanding some of those flow paths, circulation bottlenecks, things like that. So we're going to talk a little bit more in detail in a case study in just a little bit. In terms of human behavior, there's a number of different parameters to be evaluated in developing these models, and a number of different considerations. But I think one of the most important is really trying to visualize and understand what happens if we were to put ourselves in the shoes of the occupants in a situation. So the way that people might behave in something like a transit facility that we have simulated up on the screen might be different from a grocery store or a conference center or another different event. So understanding how humans are responding and behaving in those situations is very important. And of course, we're getting into COVID-19. So when we're getting into these different concerns based on best guidance, based on this new situation that we are entering into, how do we implement that? And what does that mean in terms of incorporating these different elements into our models. So many people on the call are probably familiar with Pathfinder. It's one of a number of different available tools that can be used to simulate pedestrian movement. But working with some of the Pathfinder developers, we've actually incorporated a social distancing feature so that we can see these bubbles, if you will, that represent a 6-foot separation from adjacent patrons, agents, occupants. And we can see based on the simulations that people really are somewhat effectively trying to keep the distance from each other where possible. So something like this can be used within the model to try and enforce as best as possible, acknowledging this simulation, this sort of behavior that is considered to mitigate the risk of transmission. We also have to think about some of these temperature checks, and I think this starts to become more significant for some of these larger events and understanding what that means. I think we've all probably seen it, at least I personally have, going to the grocery store, many of us have probably had to wait for 15, 20, 30 minutes just getting into a relatively low populated location because of these temperature screenings, because of trying to control the number of occupants and the interaction within the store. So we could look at that at a small scale in our personal experience and think, what does that mean if we start to have hundreds of people or thousands of people? We need to make sure that we're prepared for these sorts of situations. And then in addition to that, in this pre-COVID environment, when we're looking at occupant flow within spaces, we all kind of go the different directions that's going to be most convenient for us. But it's this new environment where we really are trying to minimize the amount of interaction between people. It could be beneficial to start to incorporate different directional flows. So this is an example on the right here that shows the occupant flow going in kind of a clockwise direction, but showing that by implementing this sort of procedure, they are minimizing the amount of interaction. And then in addition to that, there could be benefits. It could be more efficient. And so when we're looking at some of the time considerations associated with this sort of flows, we're able to evaluate what could enhance or reduce the amount of time to evacuation. We can also decrease that. So one of the key aspects of this is, one, kind of the power and be able to simulate the built environment, realistic conditions and behaviors, being able to iterate, to work with clients. And so we can very quickly make small changes to understand from a quantitative point of view what that means in terms of response. And as we've seen with the last couple of videos here, I think there's a graphical element that really is powerful, that we can see where we have a certain occupant load, we're able to have the space to be able to roam around and explore and have a bit more freedom. But if we start to increase that occupant load, perhaps that capability could be minimized. Perhaps it could even result in a condition that might have too many people where the risks perhaps should be considered in a more emphatic way. So one of the key aspects and perhaps one of the key benefits of something like pedestrian simulation modeling is being able to do something of a digital due diligence, that as we are seeking to reopen, I think that it is commendable that many organizations are really trying to put some serious thought and effort into understanding what that means and what sort of mitigation efforts are going to be reasonable, practical, and appropriate to achieve some of those business needs. There's a really interesting chart. So talking with some others in Kaufman and quite a few other people that are involved in this, looking at kind of a hierarchy of controls and what is reasonable and what is practical, perhaps, in terms of some of those controls and mitigating some of that risk. So as we start to see, perhaps we have outbreaks in certain areas, perhaps it's a higher priority location, perhaps there's a known prevalence or vulnerable populations within spaces. There are things that we can do to try and control that risk. I wish I could say that we could eliminate that risk altogether, but within the current reality of the situation, I think it is important that we at least acknowledge the steps that we can take to try and control that risk, of which pedestrian simulation modeling is one of those tools. So with that said, we're going to hop into a case study. I see some questions coming in, so I think we're going to save those to the very end, but please feel free to put those in the Q&A. We're going to launch into a case study. So this is an art gallery that we were working on. Assembly Occupancy generally tries to have large events, exhibitions, lots of different installations within these spaces. And so large open space, generally a positive location where people are able to roam around and engage with people. But again, when we're looking at the situation on the right, which is what we were used to doing, perhaps putting some thought into, are we able to have these events and achieve some of these best practice guidelines to mitigate risk? Even before getting into the model, there's some questions, concerns. And so one of the first aspects is understanding the environment. So looking at the situation we have here, we have a large open to air arcade on the outside where occupants are able to roam around within the space at their leisure. We have an entry location, an entry mezzanine up on top where occupants are greeted by staff and given a tour, verbal tour of the space and handed some pamphlets and information, are told about some of the different artists that have artwork featured. This location has a very strong connection to the local community and likes to emphasize this. And this is part of their business needs, I'll get into in just a second. So it's important to be able to interact with people in this way. We have a large vertical communication stair that's going to go from our entrance lobby down to the lower level and trying to accommodate being able to get down into this space down here and then having a number of installations, artwork, galleries, features, displays within this space. Traditionally trying to enable people to roam around and really explore at their leisure, but of course, within this current environment, perhaps rethinking that capability and trying to incorporate some of those COVID-19 implementations we talked about before. So even before we perform the modeling, it's important to consider some pre-modeling evaluation is one way that I refer to it. So knowing our business, and part of knowing our business is knowing our site, knowing our patrons. So how are occupants going to be performing in that space, interacting with each other, with the artwork, with staff, and then knowing what some of those priorities are. So of course, we as designers might have the background and the tools to be able to simulate some of these parameters, but it relies on a very strong collaboration with the clients, with the organizations. Of course, they know their organizations best, they know their operations best. So it really is seeking to work with them as closely as possible and try and get back to what the old normal was, but implement some of these tools and really validate them through an iterative process to come up with a reopening strategy that can get as close as possible to achieving their needs, but at the same time, trying to provide that risk mitigation that would be probably a good idea to incorporate. So what does that look like? This organization is a bit unique. It's a nonprofit. And so, as I had mentioned earlier, one of the key aspects here, and this is something that was really kind of fascinating and insightful for me, is the emphasis on their financial structure being donation-based. So what they've found is one of the most positive things that they can do in terms of soliciting donations is increasing that interaction and the understanding of the patrons with the artwork and the artists and the strong ties to the local communities. And so they have lots of sessions in which they're trying to bring patrons in and sit down and have conversations and bring in the artists and talk about what this artwork means to them and be able to engage in these conversations within this proximity that perhaps we're not able to achieve to the same degree that we had before. And then we can see the entrance on the right over here. This is the entrance lobby. We're moving a desk right into the front area over here, having to create a physical barrier. But what we're seeking to do is try and create a space in which staff are able to engage with patrons and engage in that more conversational environment around the history and the meaning of the artwork, and to try and create that connection. And of course, that relies on somewhat of an intimate experience with staff, with patrons, in this environment that could potentially result in higher risk. So there were sorts of business realities that needed to be incorporated, and then we as designers do our best to try and incorporate that. And of course, perhaps one of the more straightforward considerations is going to be around the architecture and the engineering of the space. So where are those high-risk locations going to be? of course, at this entrance lobby, but this is part of the business reality of the situation. And so what can we do to try and mitigate that risk, perhaps through greater ventilation, perhaps through creating those barriers, different sorts of measures that can be used. Looking at the vertical flow paths, so especially at the top of the stairs and the bottom of the stairs where we could have a larger occupant load, was something that we sought to try and pay attention to and try and minimize the densities within these spaces. One idea that we also had was there's actually an exit stair that is in the middle of the gallery. And what if we could use this exit stair and we had a one-way directional flow where you enter through, you go through the space and you exit through the exit stair. And so we're minimizing that, that pass-by of patrons entering and patrons exiting. We thought it was a good idea, but the organization appropriately pointed out that because of the importance and the reliance on that interaction, not just engaging them as they come into the space, but especially exiting the space, that they have donation boxes at that exit that is manned. That was actually something that's a real priority for them too. So it's good to know it's available to us, but this is something that we're seeking to try and incorporate these risk mitigation efforts without the use of that stair in this case. Getting into some of the patron behavior, and again, each environment is going to be a little bit different, but this one is a bit unique with a gallery with artwork that this might be a little bit different than a lot of the spaces that we generally think about that we might spend some time in. So really putting ourselves in the shoes of the patrons and working with the organization to understand what is the experience that we're trying to curate here. So there's a number of quantitative factors associated with that. Arrival times, probably one of the biggest is going to be how long people are going to be spending within this space and how many people are going to be within this space. So one could have looked at it and taken the area, divide by say 30 square feet, 36 square feet, and calculated an occupant load. But what does this mean in terms of the user experience? What we seek to facilitate is a very intimate experience between patrons and the artwork, that we want to enable different occupants to be able to approach the artwork, get close to it, really examine it to a high level, and to not have to worry about the proximity of people next to them or the flow of people around them, to have a more comfortable, something of a safer environment for them to be able to focus and have that higher level experience with the artwork and the installations that's going to be within the space. So it's not an even distribution in terms of the number of people or the square footage. We would anticipate a higher density and try and encourage and facilitate a greater number of people close to the installation, with the understanding that within some of the bigger spaces, perhaps that's where people can flow around a little bit smoothly. And of course, knowing our priorities as well. So that curated experience is going to be one of the key factors that's seeking to be incorporated and achieved, in addition to, of course, staff and user well-being, patron well-being, and some of those business objectives. And so what we did is identify something of an acceptance criteria, if you will, acknowledging that it really is somewhat elective for this organization in particular. Within the larger cultural group they're a part of, there is a mandate to come up with a reopening plan, but this modeling pedestrian simulation is elective, and I do think that it is commendable that they decide to engage and to take the next step to be able to simulate and really predict what this performance, what the response is going to look like. So within that built environment and starting to build our model, having done our homework, if you will, and working with the client, understanding some of these business needs, goals of the organization, looking at the different areas in which people could potentially move. So we have our outdoor space, getting into this lobby area, having our gallery down on the bottom, understanding where our vertical paths of egress are, where our high priority locations also might be. Working with the organization to understand where the installations are, what some of the feature areas within the gallery might be. As I'd mentioned before, kind of organizing where some of these obstructions are, so we know that occupants are not able to go to these locations. But at the same time, we also know that we want to encourage them to be able to be more dense around some of those art galleries, around some of those installations. And perhaps what that means is it's kind of open space in here. So we're not going to have that equal distribution in the way that we might calculate an occupant load for traditional occupant calculation. So getting into our model and trying to incorporate this behavior, we built the front of house, the back of house, some of the key domain areas within this space. So we have our entrance up over here, we have our vertical stairs, we have our gallery spaces, we have our installations, and we're acknowledging that we are trying to create positive effects and behaviors within this space. And one way to do so is through these physical means. And so you see these red circled areas, clouded areas with stanchions and barriers. And what we're seeking to do is try and direct occupants to behave in a certain way and try and minimize the amount of staff engagement, really let the patrons police themselves to social distance themselves, especially given some of the limitations in the number of staff and the capabilities and responsibilities within that space. So one-way flow into the space, we're trying to facilitate this kind of counterclockwise movement. So you come down these stairs and you can explore in this general direction, come up the stairs exiting out, and then we have our greeters and donation locations at the entrance, at the exit, but try and minimize some of that interaction again. Quantifying some of those effects, and so what is the average, if you want to call it processing time or that greeting time, somewhere in the order of 30, 45 seconds. And so simulating that waiting that would be anticipated in the same way, if we were to have a temperature check or some sort of screening, we can also accommodate some of those waiting times and understanding what some of that queuing could potentially look like on the outside. In this case, we were able to evaluate the duration and the approximate length of what that might be. And so this organization is putting information on the outside to try and further engage with their occupants even before they come into these spaces, which I thought was a rather elegant way of making people being okay with some of that waiting a little bit more. I wish the grocery stores did the same. Duration, of course, is a big factor there. It can fluctuate. There's averages. We can play with distributions. And so identifying some of these key criteria and then modeling within the space. And then also acknowledging some of that wayfinding, if you will, that we really are trying to curate an experience and a directional flow, some of these through these physical implementations. And we can simulate that within our models as well. So in a way, we create waypoints that we are trying to direct people. And so again, people are not robots. We in spaces do like to have freedom. But what this does is this gives us a tool to be able to evaluate in both a quantitative and a visual assessment of what sort of response, what sort of proximity are we looking at based on a population, based on arrival, based on duration, a number of different factors. And again, these are all different parameters that can be varied based on the unique needs and opportunities of a space and an organization. So we finally got into the simulations, building up to everything, very much an iterative process, but understanding what this means and what does this look like in terms of what could potentially be anticipated on these sites. So we can see based on the wait time that we have greeters up at the top, we have occupants that are entering into the space, that are spending time with some of the artwork, but we can see based on the occupant load of about 20 people to start with, that in general, just graphically and visually, we can see that they have a good amount of space to roam around. In many ways, this can be considered a positive outcome in that the occupants are able to engage in that intimate and meaningful way with the installations, and they're not necessarily on top of each other, or maybe there is less consideration or less concern around some of the social and physical proximity between some of these occupants. So in many ways, this was seen as kind of a positive outcome. So of course, we as engineers, seeking to be as efficient as we can, decided to push a little bit further. And what happens if we increase the occupant load and we have 50 patrons instead of 20 patrons? We get a slightly different outcome. And so in this way, I think it's positive that we're able to perform the modeling and evaluate what that means. So we have a greater arrival rate because we have a greater number of people. We have a greater number within the space, and we're graphically seeing that maybe this isn't the performance that we're really seeking to encourage or facilitate within this location. That yes, we do have people being able to be located adjacent to some of the artwork, but we're also seeing that it's a little bit less flexible in terms of their ability to move while maintaining that 6-foot separation from each other. So visually we can see this, graphically we can see this, and we can also quantitatively evaluate. So here's an example of one of the heat maps that can be used to highlight some of these higher priority or higher risk areas, is another way to look at it. So in this case, we can see that, especially at the bottom of the stairs, there's a feature wall, a partition wall right over here in this location that has a bunch of information that as people are coming down, that they likely want to stand around it. But if you have people that are reading this feature wall in this location, are they able to maintain that 6-foot separation from each other? In many cases, perhaps not. So perhaps they continue on past it and they start to go about their experience. And we're finding that as we have people coming back one direction and then coming back around, some people might go to the left, some people might go to the right. And what does that mean in terms of their interaction, or the term that's used here is social linkage, that we have these higher priority areas. So what does that mean? We can decrease the number of patrons. We could potentially put staff in these locations to try and manage that flow, that interaction a little bit more. A number of different tools that can be utilized. Perhaps we could even change the location of those physical barriers to try and minimize that overlap between. So there's a number of different things that we could do in order to try and encourage perhaps a slightly different outcome. So looking at a third scenario where we're acknowledging maybe 20 people is not quite enough and we can get more people in there, maybe 50 people is a little bit too many. And so let's walk it back a little bit. Looking at a situation where we have about 30 patrons, and then we can actually vary the duration. So we played with a couple different durations here, a couple different rates. There's a number of different parameters that we can look at. But in this case, what we're seeing is with this occupant load, we can see that this is probably more indicative of the experience that the organization is seeking to curate within this space, in that we can see that people are able to explore a little bit more with a little bit more freedom and less concern about some of their neighbors or some of their other fellow attendees within this space. So in general, something that was seen as kind of positive. And you can see how this was very much an iterative, a collaborative process in terms of coming to a situation that can be considered acceptable for an organization. So in terms of this organization, they're actually reopening next week, which is going to be really interesting. So especially timely that, yes, they were mandated to come up with something of a safe reopening plan. What they're able to do is incorporate some of these lessons learned through the modeling, some of this management behavior in order to really cultivate the experience that they're seeking to emphasize and facilitate within their space, primarily through some of that occupant capacity of knowing what a reasonable number of people might be based on the capability of the space. The directional flow was probably one of the biggest items that was incorporated, but again, there's some room to look at different situations there. And then of course, staff management is another one. So enabling occupants to be able to really police themselves and to allow the staff to focus on some of their other responsibilities and focus a little bit less on making sure that some of the occupants are socially and physically distancing. And again, that's all part of the operational refinement process of understanding what can be acceptable and what can't. So this, I think, is a pretty good example of that digital due diligence, if you will, about how we can use some of these tools to help inform some of this reopening process with this organization in particular, but equally so with a number of different organizations and situations. So kind of wrapping all of that up, there's a number of different considerations that go into reopening. I think it's probably a safe assumption that no one wants to see a second shutdown again, nor do we want to see a second wave. And so I think it would be reasonable and hopefully responsible to think about the things that we can do to achieve our business needs, to try and mitigate some of those risks, and then be reasonable and use logic and our understanding and information and in some cases go through that hierarchy of control and perhaps utilize some of that engineering analysis, of which pedestrian simulation modeling is one of those tools potentially, that can be used to try and mitigate that risk and hopefully try and control some of this behavior and hopefully try and decrease some of those increases that we're seeing of positivity, of transmissivity, of hospitalization, some of these factors that we see every day. So we looked at a small scale example, but what happens as we can see this trend of different organizations and larger organizations starting to reopen? What could this potentially mean, and how can this tool potentially be used for these locations? I'm sure many of us, having gone to larger colleges and being very excited to go to sports events in particular, of course, want to spend as much time as we can tailgating, and there tends to be a mad rush right before kickoff or first pitch or whenever the different event is. And what could potentially happen if you have this sudden rush of fans that are seeking to enter into these facilities? But what if we have these screenings now, and what if we're putting more importance on these wait times? What does that mean in terms of ingress and going into these spaces? Perhaps we want to be strategic and have timed entries. Perhaps we might want to have fans go to certain gates that are going to be closer to their seats compared to others. Perhaps there's different depths or lines that we should create in order and management procedures to make sure that this behavior is going to be socially and physically distanced. Maybe 25% is appropriate, maybe 50% is appropriate, but there are tools out there that can be used to come up with an analytical number that can achieve certain criteria beyond something that could be perceived as somewhat of an arbitrary number. And what about our schools and universities? So I'm particularly interested to see the work being done with the University of Maryland, especially as this tool is being applied to that. But there are a number of different considerations associated with that. And I think it's really positive that schools, childcare, youth, and universities all the same are putting some serious thought into how to socially and physically distance, into sanitizing, into mitigating some of those risks. And perhaps that could be phased teaching schedules, utilizing as many offices and classrooms as you can, perhaps a combination of distance-based web learning and in-person learning. Perhaps that's something that's going to be coordinated with mass transit systems to try and facilitate certain groups of people being able to come at certain times. A number of different questions that can be considered, and it's positive to see that a lot of these questions are being asked. And then what about indoor events? It seems like there could potentially be an increasing number of indoor events, potentially with larger groups of people. And what are some of the considerations around that? So of course, it seems like a good idea to socially and physically distance. It seems like a good idea to wear masks, but just being aware that there are tools that can be available to try and mitigate some of those risks as best as possible, not just through this modeling, but there's a significant amount of guidance. And I would emphasize going to CDC and other organizations that do have a good amount of information out there. So kind of wrapping everything up, we talked a lot about due diligence. There's a number of different priorities. We're all seeking to try and get back to what could be considered a new normal, and simply being aware of what aware and realistic of what some of the risks are and what some of those mitigation efforts are, and being informed and putting some thought into what these spaces could look like. What is the experience? What are the business realities? What are the potential threats and risks to occupants, to ourselves, to our neighbors, to our communities? So with that, that's kind of a summary of pedestrian simulation. I want to give a little bit of a teaser. So we focused on social and physical distancing in this talk today, but I want to emphasize that there is quite a lot of information around some of those HVAC systems and building controls. And one group in particular is ASHRAE. So a lot of HVAC specialists focused on an epidemic task force, working with CDC, with OSHA, with a number of different organizations to pose the exact same questions that we're asking ourselves, but what can we do within the built environment, within these engineering controls, to try and mitigate that risk through increased ventilation, through a number of different factors. So there's a number of different questions that I think perhaps appropriately should be asked, and there are things we can do, and where's the real value, and where is it financially viable to be able to do so to try and mitigate some of those risks, especially when it comes to some of those passive controls that we have around controlling our environments. And there's also analytical tools that can be used. So this is an example of one through NIST, a program called CONTAM, which some of us might be familiar with in the FP world that has traditionally been used with smoke control, which of course we all know Jim is absolutely an expert on, helped to develop a lot of these systems. So similar to simulation modeling, repurposing some of the tools that we might use for airflow environments into this new COVID-19 situation. So just a little bit of teaser of things that are happening in other parts of engineering, other parts of risk mitigation, all seeking to try and reopen as best and as safely as we can. So with that, thank you for your time. That's all I have. I think we have a little bit of time for questions. I know we have a little bit of a Q&A, but thank you for your attention, and our contact information is on here if you have any other questions. And I also put, for AIA credit, if you scroll to the top of the chat, there's a link in there, put all your information in, and everything should be in there. We'll issue those certificates. So thank you very much.
Thank you, Robert. We can go over to the questions. I have gone ahead and answered a couple of them, but I wanted to leave Robert with the pleasure of responding to a few as well. And I think there were a couple more suited for you, quite frankly. So if you, or John, do you want to be the moderator to direct us to questions, or how would you like to do this?
Okay, sure. So the first question really has to do with more confined, not confined space from the OSHA definition, but working in close quarters with people. And specifically, the question was around NFPA 25 and doing final acceptance in like a close quartered fire pump room. So Jim, do you want to sort of hop in this, or do you want me to sort of lay the groundwork for it?
I'm happy for you to lay the groundwork, or Robert just to go ahead and have at it.
Yeah, so when I saw this question, what came to mind was, yes, we're talking about social distancing, which is limited by our physical environment. But something that Robert did throw in, and I'm sorry, I don't know what slide number it was, is the hierarchy of controls. So if you find yourself having to execute a job or an activity in a space where you can't maintain that social distance, we need to go back to that hierarchy of controls and look for another mechanism to provide an added layer of protection. That might be additional PPE, personal protective equipment. It might be a different way of ventilating that space so that you can execute the work. And a third one would be limiting the time of that close coordination in that small space. So I think we have to look at some larger risk mitigation measures to address the areas where we can't maintain that social distancing. Robert, any comments on that?
That's great. I fully agree with all that.
Okay, the second question that came in had to do with the red circles around the people. And the assumption is that a 3-foot radius, meaning if you get 2 3-foot radiuses coming in together, you get the 6-foot distance maintained?
Yeah, that's correct. And so 3-foot radius. So this is based on best practice guidance. It is interesting to note that in certain situations, some organizations are actually seeking something larger than that. And so the benefit is with the Pathfinder, with the modeling tool, we can actually vary what that distance is. So we've looked at, I'd say 6-foot separation, so 3-foot radius is the default, but we've looked at 4 or 5 feet in some cases for certain conditions.
When you're doing that, this is not a question, but in this discussion, it just struck me. I noticed in one of the simulations where people did have to pass on the stairs. Does the simulation sort of give you a flag, hey, these people just came within 2 feet or whatever, or how does that work?
Yeah, it is. So One, I guess the qualitative term that the program uses is social linkage, but one way to think of it is interaction. So anytime there's an interaction of these bubbles, it's noted in the program. And so based on the heat map, we can look at where it's a combination of the number and the duration of interaction. So we're probably more concerned, like you just mentioned, a little bit more concerned with the duration. So in some cases, like a single path of egress, where it's going to be challenging for people not to pass within a certain proximity of each other, it's important to acknowledge it. But at the same time, because of the duration of that exposure, perhaps that's going to be a lesser risk relative to people being closer together for longer durations in different environments.
Okay, great. Next is, do you have any case studies for construction sites, specifically large ones?
Not yet, but it's really interesting that probably about a week and a half ago, chatting with one of the large developers in the Seattle area that is looking to do exactly that, especially as Washington is just starting to reopen their construction sites. So what are the things they can do? One, due to COVID-19 for social and physical distance, but two is actually really interesting that we were chatting to them. They're looking to utilize this even in non-COVID conditions to understand kind of the efficiency of different trades and locations and operations on a job site altogether. So that was actually really fascinating for me that they were seeking to take this even beyond COVID-19.
Oh, cool. Okay, next. Actually, can you read this one? Training and behavior modification necessary for people to actively engage in social physical distancing. The challenge on this is how to do this on a huge scale or massive scale. Have you had any discussions around that topic?
Yes, I would fully agree. It's a really big challenge. I think getting people to behave in certain ways and to listen is always going to be an issue. So right now, let's not consider evacuation scenarios because that's a little bit different. But in, say, everyday scenarios, probably one of the best considerations is acknowledging and perhaps being realistic that we can't control people as best we can. And so I think that it's very positive that a number of organizations are very proactive about some of the markers and a lot of the signs, signage, things like that, and CDC and others, local institutions. So I'm down here in San Diego. The city of San Diego has placards that are required to be posted in different locations. I think that's one tool that can be utilized. One would hope that patrons are aware of this and try and actively do this. In addition to that, trying to be realistic that for different organizations with a limited amount of staff, I think that it's a good idea that they try and be proactive about encouraging a certain behavior. A lot of it's probably due to their limitations and being realistic that the ratio of staff to occupants is probably going to be relatively low. So how much can they reasonably do? So it's difficult. I'd say we do as much as we can in advance and try and create conditions in which people are able to socially distance and physically distance themselves, but with a greater number of people and perhaps with other factors. I was chatting with Bob this morning about maybe certain locations and occupancies in which people might imbibe in certain things. Maybe some of that behavior is going to be controlled a little bit less. So with a lesser number of people, maybe that creates a little bit more flexibility on being able to distance. So I think really knowing the situation, knowing your patrons, knowing their condition is really key to try and coming up with a positive result.
Mm-hmm.
Do you have anything to add to that?
Not me. Okay, next question is, it looks like this type of analysis should take place at the completion of schematic design. Is that correct? What I think is interesting is I think the context you were talking about is actually applying this to existing facilities so that we can reoccupy them. Is that right?
Yeah, I mean that's been the perspective so far, or the emphasis here. I mean that's the application we're providing at the university. Though one could say, being proactive in this area and considering the design of buildings, new buildings coming online in the near future, if this is a problem that's going to be with us for a while, or God help us, the next pandemic, that designing buildings intelligently to be able to deal with this, I think that makes sense.
Yep. Okay. Okay. Next question. Does this assume that normal emergency evacuation using closest exit, et cetera, will be in place? Robert, you had mentioned that, you know, the emergency exiting is a whole different topic area. What did you mean by that?
I've talked to a number of different people about this, and I think there are legitimate concerns around occupying spaces and being able to evacuate in a way that is considered safe. If we look at it in terms of kind of a threat assessment, if you will, think about a fire scenario, for example. I think in terms of the level of threat, the fire might be more threatening than COVID. And so I think in this situation, we would probably accept a certain amount of proximity in order to be able to evacuate to a safe location. And so I think it's good to be aware of the need to social and physically distance, but at the same time, in terms of life safety for these evacuation scenarios, perhaps there is another consideration that might even trump a pandemic.
Okay, great. The next question has to do where the AII CES info is. Robert, you had chatted that out on the chat function. You should have received it. I just copied it and resent that. It's under the chat function, and then you can click right from there. Is that right? Okay,
yep.
Great. And that one's done. Then there's a comment to add to Dr. Milkey's response to a question about, I believe, availability of other modeling tools. There's one developed by ARUP that has similar capabilities. Does anybody do either of you guys know about that model?
I do know about STEPS. I wasn't aware it had this capability, but again, not surprising given the time we're in, and there are a dozen or 15 different evacuation simulations, I think, that were written up in the last SFP handbook that are contemporary models, and it could be that have adapted to this at this point worldwide. I do appreciate the comment, though. I wasn't familiar with STEPS having that capability. Good to know from my own knowledge that, what is the inventory of models that do this kind of thing.
Cool. Thanks, Jim.
I might add a little bit. So I've worked with that program before, and we actually looked at programs called Mass Motion that ARUP uses very frequently, and I was at ARUP use as well. So very, very, very similar to Pathfinder in terms of the applicability. It also has a social and physical distancing capability. I think graphically, it's a little bit different. I think one of the things that attracted us to Pathfinder when we were looking at which one to use was maybe it seems a little bit hokey, but having that red bubble around people, in my opinion, is a very positive and helpful graphical tool to indicate whether or not people are socially distancing from themselves. And so that and a strong experience and kind of a history with Thunderhead and with Pathfinder all kind of contributed to us going down this route with Pathfinder. But yeah, as Jim said, there's a number of tools out there that are available.
Okay. Next one is about the 3-foot radius can be a challenge when trying to account for furnishings or functions. Can you actually adjust the furnishings in the model? So were you able to adjust things to actually help the flow and maintenance of the social distancing?
Yeah, we can. Any of the barriers are flexible. And so within that model, the obstructions and the domain itself is all subject to what we think is appropriate. So to give you an example, if COVID is still around, the next time the gallery decides to have a new exhibit or installation, then what we can do is we just put the new one in. And if they decide to move some of the pieces around, kind of the same sort of thing, and also just shift things. So it's very flexible in that way.
Okay, great. Do you have case studies for schools, particularly elementary schools?
That's a really good question. That's one that we're starting to get into a lot more. So not really at liberty to talk too much about any of the details around that because there's a lot of considerations and very unique considerations for this population in these environments. But yes, this is an area that we're seeing increased activity and in my opinion, a positive concern around putting thought into how we're going to re-enter these locations.
Okay, cool. Next question is about liability. So would an FPE and or an end user that gets provided a model like this be subject to more liability if there's not a disease expert or infectious disease person involved? Have you guys addressed that at all?
Yes. One of the first things we did after chatting with Bob about investigating what this could look like is talk to our in-house lawyers and understand some of the potential litigation associated with that. And so what we seek to do is emphasize that this is based on professional guidance from reputable organizations like the CDC, WHO, OSHA, things like this. And we wish that we could eliminate risk, but we're simply trying to mitigate and reduce risk as much as possible. And the reality of this situation is that we are putting ourselves at risk when we enter into these environments. So there are controls and there's analyses and there's things we can do to try and minimize that. But unfortunately, right now, there's no way to eliminate that risk. And so as such, we're not able to guarantee that that can be completely eliminated.
Okay. Any recommendations on fire drills in schools, conflicting needs to get the kids out quickly versus the social distancing?
Jim, you want to take this one? I mean, I can, but it's great to hear from you.
Yeah, well, I mean, yeah, you're right. I mean, it gets back to the risk word that Robert's used several times here. You know, you need to do fire drills for the schools, so the students know how to react or where they're supposed to go. You know, and at the same time, you're right. If you're having everybody line up, and back in the day of that I recall putting my hand on somebody else's shoulder in front of me and walking out single file kind of thing, and maybe you don't touch anybody anymore. I'm giving you an idea of something from a much older era, probably, but certainly social distancing wasn't a piece of that. So yeah, I don't know if there's an easy answer to that. Short of having everybody walk out single file 6 feet apart, sort of thing. So still to understand what the route is to get to the exit door. But otherwise, I don't know really. I don't think there's a nice, clean, easy answer for that. I see why you gave it to me, Robert.
No, I think they'd rather hear from you. I've been talking too much already.
Actually, so a chat popped up. So in the tool, can you actually look at running a one-way aisle scenario? So could you actually run a classroom of students and see how long it would take to evacuate that room with the one directional aisle and social distancing? Mm-hmm. Oh, okay, cool.
Yeah.
So you could actually run a baseline model and then do it with social distancing and look at what your added evacuation time would be estimated at. Yeah, okay, cool. All right, we got that one. Another comment on ARUP. Was there a model called STEPS? Are either of you familiar with a STEPS model?
Yeah, we had addressed that a couple questions ago, John. So
okay, sorry about that.
There. Yeah, that's right. The one question from Cheeto is left on groups.
That got hidden on mine. Sorry. Yeah, go with that one, Jim.
Okay. So I mean, more for Robert, being he did the case study. Were you able to include groups of occupants in the case study? Is there a way to apply the social distance rule for groups as opposed to individuals not in part of a group?
Yeah, again, another good question too. So this is a functionality, maybe one of the limitations of Pathfinder right now, but this is something that we're working with the developers on to be able to incorporate kind of that group behavior. And I think this is especially important for some of those larger situations where it's reasonable to expect that you have groups of 2, 3, 4 people that are able to be close to each other, but should be separating from other groups. So that is something that's currently in development right now, but for this purpose, we didn't use it for this case study.
Okay. And then the last question, from an owner's perspective, what's the approximate cost or fee to do this type of modeling? And what are the parameters that cause the fee range?
That's a good one for Robert, I think.
Are you sure you don't want to take this one? I see, is Bob still on there right now?
What's your grant?
I know that's right, huh? I saw someone write in the question, it depends, and I think it does kind of depend. So it really depends on the number of situations, the domain that we're looking at. In this case, this is a small scale model, so it's relatively quick and easy to perform something like this. But of course, when we're looking at potentially tens of thousands of people, and we're looking at maybe hundreds of thousands of square feet, we're looking at a campus or something like that, or something even larger perhaps, then there is a lot more effort that goes into it. And so it's all kind of relative. Long story short, for a lot of the simple models that we'd be looking at, it's relatively quick, I'd say a week or two. And in terms of duration, coordination, generating models, getting to a response. And we acknowledge there is a time aspect to this as we seek to reopen. So we try and be realistic about that. And again, also realistic on the costs as well. So it's all kind of relative.
Mm-hmm. Okay, that wraps up the questions. Robert, Jim, thank you very much. Wait. Okay. One more question popped up. Yes, we'll reach out on that last question for offline discussions. If there's no other questions, I leave it to you guys for any last thoughts or comments. Robert?
Sure. I just want to say thank you to everyone attending, and thank you to University of Maryland, John and Jim especially, for participating with us and inviting us to be a part of this. I think it's great to see the partnership between organizations in the industry. That University of Maryland is obviously huge to the FP industry, and to be able to share and contribute the things we can do to try and create safer spaces, I think is a huge attribute and a huge contribution. So it's something I'm very proud to be a part of. So thank you.
Great, thank you. Jim, anything to bring us home?
I mean, I'll say, give thanks the other way to Robert and your team, Bob Libby especially, for bringing this to our attention. Very, very much appreciate that. Very much appreciate your support in helping our student team get started with their analyses. They're off and running at this point, by the way. So no results yet, but they're engaged and doing, working through it. So do appreciate it. Do appreciate all the questions, the attendance here, and it was a pleasure to be able to present this material to you.
All right. With that, we will close out. Thank you, everyone.
Thank you.